This is the screencast for section 4.3, example 4, reading the graph of the derivative. All right, so the graph of the derivative of a function f on the interval -4 to 4 is here. So if this is the graph of the derivative, I'm already going to mark this with f prime of x. So I know that I'm looking at the first derivative, kind of like the velocity graph. Answer the following questions about f, justifying each answer with information obtained from the graph of f prime. Okay, here we go. Part A, on what intervals is f increasing? Where we're looking at f prime of x, the derivative. I want to know where f is increasing. So if f is increasing, so if that was f and f was increasing, that means it would have positive slopes because it's going up. So I'm looking where the derivative is positive. So the derivative is positive from -infinity, well, really we're only looking at -4. So from -4, meaning I'm going to put closed dots on the end of this, from -4 to -2, but not at -2. At -2, it's not increasing or anything. It's instantly stopped because the derivative's value is 0. Then from -2 to 1. Part B, on what intervals is the graph of f concave up? Okay, so if f is concave up, it'll look like this. So it's increasing concave up. That's what we know so far. Concave up, its slopes maybe start out at 0 and start getting bigger and bigger and bigger. So the slopes are increasing, meaning the derivative increases. So the derivative is increasing between -2 and let's call that 0, as well as 3 to 4. So increasing here and increasing there. Part C, at which x coordinates does f have local extrema? Well, f is going to have an extrema where f, the original function, changes from increasing to decreasing or decreasing to increasing, which means the derivative is going to change from positive to negative or negative to positive. So let's see. Derivative is positive here and it doesn't change to negative, so that is not going to be an extrema in f. 1 is though. 1 is going to be an extrema in f. As a matter of fact, if the derivative changes from positive to negative, the original function is going to change from increasing to decreasing. F is going to change from increasing to decreasing. So if f changes from increasing to decreasing, that's this one, we have a maximum, a local maximum at x equals 1 on f. Let's not forget about those endpoints. So -4 is an end value of the function, and the derivative is positive after that. So at -4, f would be increasing. So we'd have like a dot and then increasing on f. So there's actually a minimum as a left endpoint of f at -4. Also, before +4, f is decreasing because the derivative is negative. So f would be decreasing and then stop, also creating a minimum at +4. So a shorter way to write all that out, I mean, you could write both of those in there, but I said that f has a minimum as a left endpoint at x equals -4 and as a right endpoint at x equals +4 because f is positive after a left endpoint and negative before a right endpoint respectively. So I kind of combined those two minimums into one sentence, one big long sentence. Part D, what are the x coordinates of all inflection points of the graph of f? Okay, well, an inflection point in f is going to happen when the concavity changes. So let's see, the slopes would be, if it changes from concave down to concave up, the slopes would be changing from decreasing to increasing, or vice versa, increasing to decreasing. So I'm looking for where that happens. Let's see, the derivative, the slopes, change from decreasing to increasing here at -2, from increasing to decreasing here at 0, and from decreasing to increasing at 3. So I can combine all those into one sentence. We don't differentiate between types of inflection points, so I can just say that f has inflection points at -2, 0, and 3 because f prime changes from decreasing to increasing or increasing to decreasing. Now, part E asks us to sketch a possible graph of f on the interval -4 to 4. So I've got some important information here, but if you're just asked to sketch a graph, you wouldn't want to go and list through all of this information because it'd be kind of a waste of time. So I am going to keep this stuff in mind, but I'm going to show you my, my strategy for graphing just kind of on the fly here. First, I draw myself two sketches, one sketch and then one official graph. So I'm going to make sure I leave room for both. Now my little sketch, I'm going to take a trip through the graph and look at where f would be increasing and decreasing. Then I'm going to take a trip through the graph and look at where it might be concave up and concave down. So my increasing decreasing trip, the derivative is definitely positive all the way through 1, but at -2 we've got this spot where it's instantaneously flat. So I'm going to put down on my x-axis here all my little numbers. I'm going to draw that it's increasing from -4 all the way to +1 by kind of drawing a little arrow like that, but I also need to show that at -2 it's flat for a second. So that's my little symbol for it. You can do that however you want to. Then f is going to be decreasing, because f prime is negative, between -1 and 4. And then I can see that I have this maximum here at +1. Now I go through and look at concavity. The derivative is decreasing between -4 and 2, so we've got a concave down situation. So I've got this increasing, so I'm going to also kind of draw a little concave down. Then between -2 and 0, f prime is increasing, so concave up. So I'm going to kind of do that. Then we have an inflection point at 0, so I'm going to mark that on my graph so I see this important spot right there when I do my final sketch. Then I have a concave up, or excuse me, concave down, because the derivative is decreasing all the way through 3. So I kind of do that. Then at between 3 and 4, on the x-axis, the f prime is increasing, so f is going to be concave up. Now I've, drawn these symbols many times. You can pass through however you would like, draw whatever symbols you would like. This is just my method. There are many other good strategies. So now I'm going to go through and draw my official graph. So I can see that I've got an increasing concave down until -2, from -4 to -2, and it doesn't really matter where I start. So there's my increasing concave down, and I've got this inflection point at -2, so I'm going to make sure and mark that on my final graph so my grader knows that I know something important is happening there. Then from -2 until 0, I have increasing concave up. And then I have another important spot, so I'm going to make sure and mark that so my grader knows that that is significant to me. I recognize that. Then we have increasing concave down from 0 to 1. And I have another important spot right there. That would be a maximum. My concavity is not very clear there. I'm going to make sure that it is very, very clear. And then from 1 until, oh, I didn't draw that little point, but 1 until 3, I'm decreasing concave down on the graph of f. And then from 3 to 4, decreasing concave up. And again, there's really no way of knowing where the graph is going to start or end. What could be below the x-axis, could be above the x-axis. You don't know that actually until chapter 5. So here's my final graph. I'm going to mark that f of x. And then maybe I'll just mark this as a sketch so my grader knows that's what I'm trying to do. The now try problem, number 23, we're going to try and go through a little bit faster. It says use the graph of the function f prime, so right off the bat I'm going to label this as f prime because I want to make sure that I don't get that confused with f or f double prime maybe. To estimate the intervals on which the function f is a increasing. Okay, so a, when f is increasing, f prime is going to be positive. So that's going to be -infinity to -2. And then again from 0 to +2, and that's it. Part B, when is f going to decrease? Well, that's when f prime is below the x-axis or negative, so between -2 and 0, and then from 2 to infinity. C, estimate the x-coordinates of all local extreme values. Well, those extremas in F are going to happen when F changes from increasing to decreasing, or decreasing to increasing. So that means when F prime changes from positive to negative, or negative to positive. So it looks like we've got 3 of those. F is going to change from positive to negative twice, once at -2 and 2. So those are going to be where F changes from increasing to decreasing, so local maxes in F. And then at 0, F prime changes from negative to positive, which means F is going to change from decreasing to increasing, meaning F is going to have that local minimum there at x equals 0. Now I added in part D, sketch a possible graph of F. So I'm going to do my, my little sketch here first. I'm going to put down my significant values, -2, 0, and 2. I'm going to do my increasing, decreasing path. So F is going to be increasing to -2, then decreasing to 0, increasing between 0 and 2, and then decreasing after. And then we know that because F prime would go from positive to negative to positive to negative. And then let's see, concavity. Well, F prime is decreasing, meaning F is going to be concave down all the way up from -infinity to 1. So I also need 1 in here as a significant value, and that's going to be concave down, meaning there's going to be a change there in concavity between -1 and +1. F prime is now increasing, so F is concave up. So I put 1 on my x-axis and show concave up. There's going to be an inflection point at 1 in F. So, and then that's where F prime then changes to decreasing, so F is going to change back to concave down. So now my final graph. From -infinity to -2, the graph is increasing concave down. So I've got this maximum that I'm approaching. Then I've got between -2 and 1 decreasing concave down and an inflection point at 1. Then from, let's see, 1 to 0, decreasing concave up. And then from 0 to 1, increasing, still concave up though. And then from 1 to 2, increasing concave up. And then from 2 to infinity, decreasing concave down. So that would be a sketch of the final graph. Now, of course, this final graph, we don't really know the y values. So it technically could be down here. It could be way down here. It could be up here. It could be lopsided. But this is a good sketch. This is a very accurate sketch of F. So I'm going to label that as F.